NFC stands for a near field communication, which is similar to RFID in terms of the task it can perform. NFC is designed to work within the close proximity, about 4 centimeters. The tag can also be passive, which requires no power and which still can be detected by scanning device, but most of the time both devices are powered. For example, when you're doing a payment, you have your mobile phone, you have the payment reader, and then you can do a payment. There is no pairing concept similar to Bluetooth, and there are no default security. So a tag could be read from an unauthorized device. Please pause this video and go and watch the video I put here on how near field communication works to better understand the inner workings. Passive devices contain information for other readers to read. However, it cannot read information from any other device. NFC tags found in supermarket products are example of passive NFC, but payment systems are active because the payment device has on transmitting capability. Smartphones, as I said before, is a good example of an active device. NFC also used for contactless payment using a smartwatch or smart cars. NFCs are also used in identity documents such as key cards. There are 4 classes in NFC, class A, B, F, and V. Based on the class, the coding, modulation, and data rates could be slightly varied. So if you think that NFC is a good technology for your IoT system, you need to go and dig a little bit more in detail to these classes and figure it out which one is the best for your task at hand. NFC has 3 modes of operation: peer-to-peer, read-write, and card emulation. So peer-to-peer can be used to swap data in between 2 smartphone devices. Read and write can be used when one active device pick up info from another passive one. And card emulation is the one that you use for contactless payment. Additionally, as you can see in the image, there are 3 different categories of usage of NFC: for connecting, for commissioning, and for controlling of IoT devices. As you can see from the illustration, there are significant tasks that NFC can be used to help the end users and configuration process and to setting up the ecosystems. NFC can be used to help connecting devices. It lets you pair a device that use different communication technology so that then you can initiate a Bluetooth or Wi-Fi transaction with just a tap. NFC can also be used for commissioning, so you can run some diagnostics or do some installation, data logging, and maintenance of your IoT network. Finally, it can also use for controlling. For example, if you can set up your own preferences in a washing machine, you can tap it and then the washing machine will take that profile as the preferred laundry profile, and it will wash the clothes based on the information in that particular transaction. So if you have something in your IoT system where you think that it is complicated for the end users to handle and do the setting up, then you can embed a NFC as a secondary mechanism to help the configure the primary communication network and setting up the configurations. And it can also be used to transfer like profiles. For example, if you have like a smart home devices connected together and you are moving houses, so when you move to a new house, perhaps you can get the entire profile of the settings, and then you can deploy to the new house quickly rather than setting up again. Or you can have like one type of device IoT device configuration set up in your manufacturing setting or agriculture setting, and then you can go and repeat that by just tapping the other sensors. So the other sensors will be configured in the exact same way because they share the profile through NFC. NFC are commonly used for smartphone or smartwatch-based payment, parcel tracking, computer games, and synchronize of toys. Again, I said like changing the profiles, moving profiles from one device to the other. NFC can also use low power home automation, and also NFC used in information tags in posters and advertisements, so people can put the phone nearby and acquire more additional information about a particular advert or a poster. Here you can see a short comparison of NFC and RFID, but some of the values you see here, you might see different values in different places. There's a reason, because when you say NFC, RFID, they are not one thing, because there are different versions and different companies implementing with the different capabilities. So some of the values, for example, range, might vary depending on the source you are looking at. So if you look at the setup time, both setup to read and make it work, it's more like a 0.1 millisecond, so less than 0.1 millisecond. Range, the values doesn't really matter, but RFID has a more range than NFC typically, because the NFC is supposed to be very close contact. RFID is supposed to be a little bit more long range compared to NFC, because you don't want to just put every object very close to the RFID to track a RFID to the reader. So when a particular good or a thing moves from the door, it should be able to read it. So that is why it has a longer range. And then if you have active RFID, then the range is more. So basically, if you want to apply this in your IoT system, you probably need to go and read the range and all the specification. But roughly, NFC shorter, RFID a bit longer. Usability, NFC is more human-centric, easy and intuitive and fast. RFID is item-centric. It's more for like industrial or tracking, not for human. Selectivity, NFC is high. There's a security provided a little bit. When I say a little bit, that means neither of them directly provide default security, but you can implement security features using third-party frameworks and techniques. So the common use case for NFC is payment, share information, share profile, easy setup, initiation. RFID primary use case is item tracking. NFC is basically a consumer experience, is about touch, wave, simply connect. So that is how you connect, put NFC into a poster or payment panel or something like that. RFID is basically to get information. So these are the fundamental differences in those categories, but within that there are a lot of variations. So as I said before, if you need either of these technologies to be used in your IoT system, make sure you go and read the specifications and actually test them to make sure that whether exactly they work as intended, because some of the specifications that they theoretically put on the websites when you buy certain components might not be fully accurate. In practical world, they might not reach the same range before as they mentioned. So this is something you need to think about when you actually go and developing these systems.